Hello everybody. In this video, we'll look at several problems that involve equations of circular motion. So let's get started. Here are the two problems that we will be working on. Let's start with the first one. Number 12 states that given that velocity is equals to 5 meters per second and that the radius is 2 meters, find the acceleration. So first, what we're going to do in these types of problems is we're going to write down what we've been given. So we're told that the velocity is equals to 5 meters per second, the radius is 2 meters, and we're solving for the acceleration. Now we're going to determine, okay, so now that we have the given variables, which equation are we going to be using? So of the two equations that were provided, we're going to use the first equation. And the reason we know we're going to use the first equation is because we see that this equation has an acceleration term, it has the a, it has the v, and it has the r, which are the quantities that we've been given in this problem. Now the next step after we determine which equation we're going to use is we're going to plug the values in. So we see that in the equation for a is equals to v squared over r. In this case, the velocity was 5, so we have 5 squared, representing the v squared, and then we divide it by 2, which is our radius. So 5 squared is 25, divided by 2 gives us 12.5, and the units of acceleration are meters per second squared. So that's the final answer for the first problem. The second problem we're looking at is we're told that originally a is equals to 12 meters per second squared, then the radius gets doubled. Find the new value for the a. So here again, we're going to do the same process, but this problem involves a little bit more work, and there's a strategy involved, and I'll go into that in just a second. So first, similar to the first problem, we're going to write down what we've been given. So we're told initially a naught is equals to 12 meters per second squared, as we're told right here, and then we're told originally a was 12 meters per second squared. Now afterwards r was doubled, but initially r was r naught, the original value of r naught. Okay, so that's why we have r naught here. Now this is a more implicit thing that we have to understand about this problem. You know, it's not explicitly mentioned that r is equals to r naught, but that's what it was initially. And also we're not told anything about the velocity as well, v naught. It's, you know, so, and actually we're not told anything even afterwards about velocity as well. So we're just gonna say in both cases, initial and final, velocity was v naught. And then we'll talk about what happens afterwards, right? So afterwards, we're solving for this acceleration. This is our unknown. And again, we're told that, actually this should be 2 here. So afterwards, the velocity still stays the same, but the radius becomes 2 times what it was initially, right? Because we're told here up here that the radius is doubled, and that's what it means. It becomes 2 times r naught. Whatever the initial value was, it's 2 times that now. And now we're solving for the acceleration. Now if you notice here, we're not told anything about velocity. We're not told that it was this before and it changed to this. So what we're going to assume is that velocity stayed constant the whole time, and that's kind of where our strategy comes in. But before that, again, you know, similar to what I mentioned before, this is the equation we're going to be using. A is equals to v squared over r, and here's our strategy that we're going to use. So again, this is the equation we're going to be using. Okay, and in this problem, our strategy is that we're going to set both of these equations actually equals to v squared. So if you look right here, we have a is equals to v squared over r, right? So what we're going to do is we're going to rearrange this equation. We're going to solve for v squared. So if you notice, if you multiply the acceleration times the radius, we're going to get v squared, right? And that's what we're going to do for both of them, for final case and initial case. And that way, what we're going to do is we're going to completely eliminate velocity from this equation, because what we're doing is we're solving for velocity. In both cases, they're the same, so we're going to equate the velocities equal to each other, and then that's how we're going to solve. So let's see how this is going to look. Okay, so here we have the initial velocity, v squared, for the initial part is equals to v squared for the final part. F is representing the final, not the 0 or the naught is representing the initial. Okay, so initially we're told that, oh, the acceleration was 12 meters per second squared. So a naught was 12 meters. That's why I put that right here, 12 meters per second squared. We're not explicitly told what the r naught was, so we're just going to put it was r naught, whatever it was originally. Okay, and then finally we're told that the acceleration, we're not told what the final acceleration is, so that's what we're still solving for. And we're told that the radius becomes 2r naught. I just put the number in front of it, okay? But it was supposed to say 2r naught here. I just put the number in front of it just to make the equation look more cleaner. Now what I do is I rearrange this equation that I have, and I solve it for my AF value. Okay, so I'm going to circle this. Okay, this is what I was solving for. So I rearranged the whole equation, so I'm solving for this. So as you can see right here is my AF value. So I take my 12 meters per second squared, times r naught, and I divide both sides by 2 r naught. And when I do that, I'll notice that this is what the equation looks like. It looks like 12 meters per second squared times r naught divided by 2 r naught. And I see, oh, both of these equations have an r naught. So I'm going to change the pointer color to green, and I'm going to cross some of the terms out. So r naught at the top gets canceled with r naught at the bottom, and then 12 over 2 is 6. And that's how we get our final answer, that after you double the radius, the final acceleration ends up becoming 6 meters per second squared. And that's our final answer. So thank you so much for tuning in, and hope you guys found this video to be helpful.